Hello, my name is Maciej Filipek. I'm a research engineer at the Austrian Center for Digital Production. This is part of a webinar series. If you want to know more about this webinar series, head over to our social media platform and watch the introduction videos, as well as other videos about hot topics that we have. This video is about advanced planning and scheduling and data-driven decision-making. It is meant for small businesses and medium-sized companies, as well as practitioners and managers interested in advanced planning and scheduling. What are we discussing in this video? What is advanced planning and scheduling? What are advanced planning systems, their modeling approaches, and then I will present 3 use cases. Advanced planning and scheduling refers basically to a production or manufacturing management process where the process begins at the raw material level, goes through production, and ends up at the demand level. So what we are trying to do here is plan the whole stage from sourcing, through production, through distribution, up to sales. The planning horizon in this context is described by a strategic level, a tactical level, and an operational level. What is the problem with advanced planning and scheduling? Basically, that existing ERP systems are used kind of in a scope for advanced planning, but they are way too monolithic to map all the optimal key performance indicators in a way that they will be feasible for the business. So they are hard to solve and they give no insight into the supply chain process or into the production process. So what to do here? Well, you can use advanced planning systems. These are tailor-made software modules designed to fit a specific management purpose. Advanced planning systems have multiple approaches to give the planner more flexibility. They are dynamic and more insight into their planning process, but only into a fraction. Compared with the monolithic approach, they're very easy to solve and they don't take up as much capacity as the ERP system itself. An advanced planning system integrates very well as a module into an existing ERP system and uses data interfaces to communicate with the ERP system. Well, the most important thing is data preparation and an interface generation for existing company data. The modeling approaches for APS systems are linear programming, queuing theory simulations, and you can have descriptive statistics for data-driven KPIs. For linear programming, we apply heuristics and meta-heuristics. We create generic algorithms, or we do exact optimization. For queuing theory, we can use rapid modeling, GGM queuing models, or MMC queuing models. This transitions very well to simulation, creating discrete event simulations, or implementing agent-based simulations. For statistics, we use advanced planning and scheduling statistics and analytics with insights into data-driven KPI creation. The first use case I want to present is a supply chain decision support system. What was the problem? The problem here was that the company had lack of transparency and lack of planning within their company. So the decision support system was required to compare different production configurations based on a mass customization level. This project proposed an analytical method applying rapid modeling to support managers in evaluating the resources, materials, and capacities per order level. Keep in mind that this is on a strategical level. The solution proposition was that the supply chain management system could compare the actual versus the planned data and could evaluate production and material KPIs as well as procurement of the purchased parts of the orders received. It shows basically the respective capacity and material consumption over time and deviations from the planned status. The second part of the decision support system dealt with future orders that were just planned. They were not accessible yet. So it's a forecast. So you could create a whole new supply chain using this method and then evaluate distant future orders. The second use case I want to present is a queuing theory approach in a quality control system. The problem statement here is how can a quality control system be evaluated by applying queuing theory with 0 waiting times? And the second problem statement, which derived from the first one, how can a system be developed to support the finding? So the solution was to create a software solution for system evaluation. So we took historical data and supported KPIs like utilization, waiting times, cycle times, work in process to evaluate the whole system. We built a network, and then in the end we evaluated the whole network to see if this claim was possible to have zero waiting times in a quality control system. The third use case is about flexible job shop scheduling. The problem statement here is how can M machines be assigned to N jobs, minimizing completion times, including a machine switching probability. The constraints here are that there can be no overlap in start and end times for any job task. Tasks within the same job cannot be started unless all other tasks are complete. The process follows a hard sequence. Each task can only be run on certain machines. There is a machine switching probability to indicate if there are two machines, which one to take. The solution that we developed here at the CDP was an APS system that created an XML input interface of the provided company data used to be fed into the solver module. Then we solved the problem using an MP-hard approach. The output was then taken and read back into an XML file and back into the customer's legacy system. So that's it for now from my side. We at the CDP provide high-end experience to create data-driven decision support. We even have a dedicated area for the purpose. If you want to know more about advanced planning and scheduling, or you want to initiate a project, don't hesitate to contact us through our homepage or contact me directly. We would be happy to provide tailor-made solutions for your problems. Check out also our social media platforms to gain more insights about our products and services. Thanks for watching and stay tuned for the next video.